Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Dafina binti Faizal Effendi and I'm from group number 5. Okay, for today, my group will present about topic number 8, which is about issues and research of astronomy. Okay, maybe all of us keep asking, what is astronomy? Okay, astronomy is the study of everything in the universes beyond Earth's atmosphere that includes objects we can see with our naked eyes, like the sun, the moon, the planets, and the stars. It also includes objects we can only see with telescopes or other instruments, like faraway galaxies and tiny particles, and it even includes questions about things we can't see at all, like dark matter and dark energy. Okay, so now we go through to my topic about current issues in astronomy, which issues that have been raised and become a question mark for many parties that are related about Earth, either the shape are flat or sphere. Okay, so our Earth is sphere or flat. Proof that the Earth's round based on the verses of the Quran, Surah Az-Zumar. A'udzu billahi minasyaitonir rajim. Khalaqas samawati wal arda bil haqq yuqawwiru al-layla 'ala an-nahari wa yuqawwiru an-nahara 'ala al-layl wa sakhkhara ash-shamsa wal qamara kullun yajri li ajalin musamma. Allahu al-'azizul ghaffar. The meaning is, He created the heavens and the earth in true proportions. He makes the night overlap the day and the day overlap the night. He has subjected the sun and the moon to His law. Each one follows a course for a time appointed. Is not He the exalted in power? He who forgives again and again. In the verse, the word kawwara, which is yukawiru, which means overlapping or circular. Overlapping or circular events alternating day and night, which is can only occur if the earth is round. So from these verses we can know our earth is round shape or sphere shape. Okay, next we go to the next slides. There is about physical evidence that prove Earth is sphere, or it is logical evidence to prove it. Our Earth is sphere and not flat. First, we can watch a ship sail off to sea. How? Without being in the sky, it is impossible to see the curvature of the Earth. However, it can see the demonstration of this if we visit any place with a wide open view of the water, which is at the sea. If you are able to watch a ship sail off to sea, watch its mast and flag as it fades off into the distance. Then you will notice that in fact it does not fade off into the distance at all. Instead, you will see its mast and flag appear to slowly sink. The ship sailed beyond the point at which you would see it. This phenomenon can only be explained by a sphere-shaped planet, which is our Earth. Okay, the next evidence is we can climb a tree. If the Earth is flat, then our visibility both under and above the tree will be the same. But when we climb a tall tree, we will feel that the higher we climb, the farther we can see. This happens because the part that was previously blocked in our view, due to the spherical shape of the Earth, becomes visible because our position is getting higher. Okay, the next is we can looking at the sunset. By observing the process of the sun setting, we can prove that the Earth is round. Okay, let's imagine we are observing the sun sinking from a place A. When the sun is no longer visible from that point, try to go to a higher place. Okay, we call it as a point B. From point B, we can still be able to see the sun, while at point A, the sun is no longer visible. If the earth is flat, when the sun has sunk at point A, then point B, even though it is higher, the sun will not be visible. Okay, so now from what we learned, we can conclude that our earth is a sphere shape or round shape, not a flat shape. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Then we continue with the ethic issues in astronomy. Okay, ethics means moral philosophy, or we can call it the theory of moral values. Okay, from these ethic issues, I have found the research misconduct. Okay, research misconduct means fabrication, falsification, or plagiarism in proposing, performing, or reviewing research, or in reporting research result. Okay. From this research misconduct, I have made some list. Okay, so uh, the sign of research misconduct is um, firstly, data reduction and measurement proceed much more quickly than recent research work by the established expert, um, which means the data of the experiment can be resulting faster than the recent research work by the established expert. Okay, for the example, the experiment result only requires a few weeks from other years. Okay, next, when the methods are examined by others, they find that shortcuts have been taken. Okay, measurement and calculation have not been double checked, and there is an absence of work to classify the result or to test for simpler explanation. So, we can see that the research misconduct is the issues in the ethic issues in astronomy.
Warahmatullahi wabarakatuh. My name is Nur Ifa Bitri Zoin. I'm from class A2202B and from group 5. In this title of issue and research of astronomy, I will share to all of you about problems in astronomy. So before we start, problems in astronomy is leisurely talk about some of the unsolved astronomical problems that are theoretical, which means that present theories appear incapable of explaining a specific observable phenomena or experimental outcome. The others are experimental, which means that developing an experiment to test a suggest theory or explore a phenomena in greater depth is challenging. Some are one-time occurrences, exceptional happenings that have not occurred again, and whose causes are hence unknown. Problems in astronomy. Okay, the first thing in problems in astronomy is planetary astronomy. Okay, planetary astronomy is basically a study of planetary bodies and phenomena by astronomical remote sensing techniques that represented a major elements of astronomy since the invention of the telescope. That includes unlist problems like planetary system and rotation rate of Saturn. And the second problem is stellar astronomy and astrophysics. Stellar astronomy and astrophysics is the study of the sun and the stars, of what they are, how they move, and how they are born, live and die. And they include the problems like solar cycle and coronal heating problems. And the third problems in astronomy is galactic astronomy and astrophysics. Galactic astronomy and astrophysics is the study of the Milky Way galaxy and all its contents. This is in contrast to extragalactic astronomy, which is the study of everything outside our galaxy, and including all other galaxy, which is include the problems, the unleashed problem like galaxy rotation problem and ultraluminous X-ray sources. Astronomy is black holes. Okay, black holes is a region of space-time where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light can escape from it. And they include gravitational singularities and black hole information paradox and black hole radiation. And we move to others problem in astronomy, that is cosmology. Cosmology is a branch of astronomy that involves the origin and evolution of the universe from the Big Bang to today and on into the future, such as like dark matter and dark energy. And the last problem in astronomy is extraterrestrial life. Extraterrestrial life is a hypothetical life which may occur outside Earth and which did not originate on Earth, which is include the other life in the universe and warp signal. Okay, warp signal is was a strong narrowband radio signal.
Hi, my name is Hairul Izzati binti Hairul Anwar with metric number 2020455974. So let's talk about the problem solving in astronomy. Okay, I would like to talk about the black holes. So what is exactly black holes? Black holes is a place in space that gravity pulls so much even light cannot go out from there. Okay, this image is a theoretical image for black holes. So let's move on to the structure of black holes. As you can see, at the center of the black holes is which is the dark color, we call it as singularity. So singularity is a region where any matter has collapsed if it passed through it. And this region is infinite density. What is infinite density? Infinite density is we cannot count the density of singularity or of the black holes. And inside the singularity, if you can see the geometrical image here, inside the singularity we have event horizon. So, or the other name of event horizon is the point of no return. So everything that go inside the singularity, it will go pass through the event horizon and it will not come back, because in the event horizon there is a high gravity, which is infinite gravity here. Okay, so we go to the outer, which is the bright color around the singularity. We call it as photon sphere. So here it has photons emitted from hot plasma near the black hole, which bend their trajectory and producing a bright ring here. Okay, outer the photon sphere we have accretion disk. So what is accretion disk? Accretion disk is a superheated gas and dust whirl around black hole. It's producing electromagnetic radiation, which is X-ray. And perpendicular with the black hole we have relativistic jet, which is if stars are absorbed by the black holes, the particles and radiation are blasted out at near light speed here. Okay, so we move on to the size of black holes. Black holes has many size, which is the smaller size. It can be 0 to 0.1 solar mass, which as tiny as atoms. And the bigger size, we call it as supermassive black holes. It can be 10 to the power of 5 until 10 to the power of 10 solar mass. Maybe it's around 6 times or 14 times bigger than sun, the size of sun or the mass of sun. Okay, so as you can see, this image is a Sagittarius A, which is a supermassive black hole in our galaxy. If you can see the blue color one, the blue color in this image is is a X-ray or electromagnetic radiation that we can capture in this image, or we can capture from the black holes in our galaxy. Okay, so how they can capture it? Astronomers use NASA Chandra X-ray Observatory to find the electromagnetic radiation image. Okay, and if you can see the red color one, the red color is we call it as infrared emission. It observatory from the Hubble Space Telescope. Okay, it captured the infrared emission in our galaxy. So for this image, our astronomers collab with all the astronomers around the world to get this image. And we are lucky because on 10 April 2019, our astronomers capture the latest image for the Sagittarius A, which is this image is more clear than before, and it's quite similar with the theoretical image of the black hole, this Sagittarius A, which is the supermassive black holes. There has a singularity, there is a accretion disk, so it's quite similar. In theoretical image. So that's all for black holes. Thank you.
I'm Nafadilah binti Abdul Qadir, and I will talk about method research of astronomy. What we can learn in this topic is astronomy method is an introduction to the basic practical tools, method, and phenomena that underlie quantitative astronomy. Essential measurement reaching 3,000 years or more were carried out in the many cultures worldwide. Early astronomy in Greece deduced important conclusions about the nature of the Earth. The solar system. Modern astronomy began in the Renaissance with the observation of Tycho Brahe and Galileo, and the theoretical work of Kepler and someone that we know like Newton. The progress of knowledge on the sky may be traced through a series of major discoveries which often follow the development of new technology such as telescope, computer, and space observatories. Astronomy also carried out across the entire electromagnetic spectrum from the radio to the gamma ray. See over illustrations, as well as with comet rays, neurinous and gravitational wave. The mutual dependence of theory and observation had led to major advance in the understanding of a wide diversity and of coalescent objects such as stars, supernova, remains, galaxies, and the universe itself. As we know, the telescope was an epic technical advance in astronomy because in effect it enlarged the eyes. It could collect all the light, impinging on the objective lens and direct it into the eyes. Since the objective lens was much larger than the lens of the eyes, more light could be collected in given time and better object could be seen. In associated magnification, allow fine details to be resolved. Galileo was the first to detect the satellite moons of Jupiter and determine their orbital periods. He showed that the heavens were not perfect and immutable. The Earth's moon was found to have a very irregular surface, and the sun was found to have dark impression now as sunspots. Next, the study of the sky continued with the development of larger and larger telescopes, and generally, these are reflective instruments wherein the light passes through the lens as in a pair of binoculars. The glass reflects the different colors of light attained. This leads to reflective telescope that make use of curved mirror in the case of wavelengths impinging at a position of mirror from given angle are reflected in the same direction. This technology, which allows telescope to compensate for the blurring of struck by the Earth's atmosphere, are now coming online. By the way, photography was an epochal development for astronomy in the 19th century. If a piece of film is placed at the focus of a telescope, the photo can be collected the period up to and exceeding 1 hour. This allows the detection of objects many orders of magnitudes fainter that could be seen by eyes. A photograph could record not only an image of the sky, but also the spectrum of a celestial object. The latter show the distribution of energy as a function of reflex of frequency. The light from the object is dispersed into its continuous color with a prisma or grating before being imaged onto the film. Large telescopes together with photography and spectroscopy really enlarge the domains of quantitative measurement available to astronomers. Then, since the mid-20th century, more sensitive electronic detection devices have come into use. Example for photomultiplier tube, the image, and more recently, the charge-decoupled detector that we call CCD. Computers have come into wide use for the control of the quantitative pointing and for analysis of the data after the observation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Najihah binti Abdul Malim. My metric number 2020455712. Today I want to present about the impact of astronomy. Okay, let's continue to the first impact of astronomy in industry. Some of the most useful examples of technology transfer between astronomy and industry include advances in imaging and communication. For example, a field called Kodak Technical Pin is used extensively by medical and industrial spectroscopists, industrial photographers, and artists, and was originally created so that solar astronomers could record the changes in the surface structure of the sun. Next, the development of technical pin, again driven by the requirement of astronomers, was used for several decades until it was discontinued to detect disease, cold, and forest in dentistry and medical diagnosis, and for probing layers of painting to reveal faults. Okay, now let's move to the next impact of astronomy in the aerospace sector. The aerospace sector shares most of its technology with astronomy, specifically in telescope and instrument hardware, imaging, and image processing technique. Since the development of space-based telescope, information aggregation for defense have shifted from using ground-based to aerial and space-based technique. Defense satellites are essentially telescope pointed towards Earth and require identical technology and hardware to those used in their astronomical counterpart. Next, processing satellite image uses the same software and processes as astronomical image. Some specific example of astronomical developments used in defense is observation of star and model of stellar atmosphere are used to differentiate between rocket plumes and comet objects. The same method is now being studied for use in early warning system. The third impact of astronomy is in the energy sector. Astronomical method can be used to find new fossil fuel as well as to evaluate the possibility of new renewable energy sources. For example, an Australian company called Engineer has created solar radiation collectors to harness the power of the sun for energy on Earth. They have created collectors up to 16 meters in diameter, which is only possible with the use of a graphite composite material developed for an orbiting telescope array. The next impact of astronomy is in medicine. Another important example of how astronomical research has contributed to the medical world is in the development of clean working areas. The manufacture of space-based telescope require an extremely clean environment to prevent dust or particles that might obscure or obstruct the mirror or instrument on the telescope, such as in NASA's Stellar mission Crewman 2011. The clean room protocol and filters and varnish strips that were developed to achieve this are now also used in hospital and pharmaceutical labs. Next, the impact of astronomy in everyday life. The contribution of astronomy is it has made to our view of time. The first calendar was based on the movement of the moon, and even the way that we define a second is due to astronomy. The atomic clock, developed in 1955, was calibrated using astronomical ephemeris time, a former standard astronomical timescale adopted by the IAU in 1952. This led to the internationally agreed upon redefinition of the second. Lastly, impact of astronomy in international collaboration. Astronomy is particularly well suited to international collaboration due to the need to have telescopes in different places around the world in order to see the whole sky. At least as far back as 1887, when astronomers from around the world pulled their telescope image and made the first map of the whole sky. There have been international collaboration in astronomy, and in 1920, the International Astronomical Union became the first international scientific union. Next, to the need to see the sky from different vantage of Earth, building astronomical observatories on the ground and in space is extremely expensive. Therefore, most of the current and planned observatories are owned by several nations. All of these collaborations have thus far been peaceful and successful. For example, the European Southern Observatory ESO, which includes 14 European countries and Brazil, and is located in Chile. In conclusion, astronomy is an important part of society. Although we have progressed mainly on the technology and knowledge transfer, perhaps the most important contribution is still the fact that astronomy makes us aware on how we fit into the vast universe. The American astronomer Carl Sagan showed us